get started. Thank you for being here. In this session is the first session after lunch, and I know it's tough, so if you want to sleep, I won't get offended. If I fall asleep, please wake me up before the session ends. And I'd like to talk about recommendation systems and how we implemented one of them. Before diving in the details, I want to give you a bit of context. A client of ours is HarperCollins, which is an American editor, and in Italy it publishes different kind of books, but mostly love books. Okay, so you know the harmony stuff and like that. It may sound funny, but they do make quite a lot of money, and they asked us to improve the user experience. They have a lot of titles, a lot of books, and they wanted to, well, start recommending, suggesting some books to their users based on user tastes. So, well, we said, okay, yes, let's do this. We started studying about how these systems works, what approaches were available for us, and, well, we implemented one. So this talk is about, well, sharing what we learned, which is by definition not everything, but is just our experience. Still, I hope that will be useful for you, and if you have questions, please just stop me during the talk, or after the talk, get in touch with me, say hi, and let's talk about this. Okay, a recommender system is a system that helps people finding things, when the process of finding what you need is, well, somehow complicated, challenging, because you have a lot of choices or, well, alternatives, okay? When I first read this sentence, I thought, well, okay, finding stuff, so it's a search engine, right? Because it helps you finding stuff you don't know it exists. Well, if you think about it, in the search engine domain, the document base is almost static, okay? You have a lot of documents, but they grow not so rapidly, while the queries you issue on this document base is dynamic. Let's think about Google. I want to find the meaning of the word banana, or finding a restaurant, or, I don't know, finding the next movie in theaters, and stuff like that. So basically, we create an index of all our documents, extracting information, analyzing the documents, and then for a given query, for a given keyword, we just compute a score, which tells us how well this particular document fits with the query we are issuing at that particular moment. Make sense? Well, it should be, I hope. Recommender systems are similar, but they work in a different way because, well, the document base usually is growing, is a growing one, okay? Think about Netflix or Amazon or stuff like that. We have a lot of documents and they grow as the time passes. On the other side, queries are usually static because I want just to find something I might like, and that's all. Okay, so when we started deep diving into that stuff, we tried to figure out what are the different kind of recommender system and, well, what are their particular characteristics. So there is a little classification that can help you, well, understand, reason what are meaningful dimensions to keep in count when talking with these systems. The first one, obviously, the domain, which is, well, the domain where we want to give some kind of recommendation, okay? It could be news, article, product, stuff like that. The domain obviously helps you defining What can you suggest? For instance, let's take the domain, the book domain, okay? In the book domain, I probably just want to know about book I haven't read, while for movies, well, it's almost the same. If we took a different domain, like, I don't know, grocery stores, okay? Well, stuff I have already tried, that could be fine, okay? That is, given the domain, you can understand what makes sense to suggest to your user. What is the purpose of the suggestion, of the recommendation? Well, it could be sales, it could be giving information to the user, it could be trying to create the community, like, well, TripAdvisor, for instance, okay? They don't want you to sell anything. They just want you to, well, continue rating restaurants and hotels and stuff like that, and having a growing user base, a bigger community. What else? Which kind of personalization level could we have? Well, we can have non-personalized recommendation, which means every user gets the same recommendation, like top 10 for music or bestsellers for e-commerce and stuff like that. We can have personalization based on some demographic data, like age, location, and stuff like that. And recommendation can be ephemeral, which means they are made by just observing the current user behavior, okay? Which makes sense, as example, in a site when the user is not logged in. So I can have an history of what he did. I have just probably a current session. I can record some data, but I need to make a decision based on the current user activity. On the other side, we have a persistent user, let's say a logged in user. Okay, in that particular case, I can register and track their behavior over time and make some decision based on more data. Types of input, which means in which way the user, well, manifests its interest. It could be explicit. Again, let's take TripAdvisor or Netflix or Amazon as an example. Okay? I say that I do like a particular movie or a particular book explicitly. Or it can be an implicit way. The user could tell us this in an implicit way. For instance, if I put a book in my wish list, well, it probably means that I might like it. Okay? And if we recall this behavior, again, we can make some reasoning about it and use it to, well, recommend something meaningful for the user. Output. Well, we can make prediction, like predicting the rating I'm going to assign to a particular item, or we can make recommendation, suggestion list. Okay? You might like this kind of stuff. Or use it for promotion or offers if we're talking about e-commerce and stuff like that. Also, we can use it for filtering data we are incoming data, like email or articles and stuff like that. Make sense? I hope so. Okay. Now there is a little model we can use to, well, make comparison, again, reasoning about the different kind of recommendation we can try to give to the user. We have a few actors in this model. First one, user, which are, well, the user of our system, people with some kind of preference in a given domain, books, movies, whatever. Items, which are the subjects of the rating. I do like a particular movie. I do dislike a particular movie. Rating is an expression of user opinion regarding an item. Okay? And also, all these objects are, well, make sense given a particular, again, community, a particular domain, which is a space where these opinions make sense. Okay? If I, well, we are talking about movie domain, well, my preferences probably doesn't mean anything if I move to another domain, let's say grocery stores. Okay. Okay, that's a graphical way to represent what I told you. We have the user, rating, items, and items are, well, characterized by a set of attributes, like properties, which again depends on the domain. If we're talking about movie, they could be, well, the actors, director, and stuff like that. Also for the user, we can have some attributes, like again, demographic attributes, age, location, gender, stuff like that. That, well, can help us, again, deciding what to recommend. The user model is, well, a representation of the user in a particular domain. Okay, so let's see how this generic model fits in different kind of recommender systems. The first one, non-personalized recommendation. As I said before, well, this kind of recommendation are the same for every user, okay? Like bestseller list, most popular, trending, stuff like that. They're pretty simple to compute in general because, well, they are just a summary of community ratings, okay? So let's say the best hotel in town. Let's take TripAdvisor as an example. We have, again, user, item, and ratings. So in the TripAdvisor domain, what are the items? Take a guess. Yeah, restaurants or hotel, okay, doesn't matter. User, well, they are the user of a platform, the visitor of the restaurant or of the user of the venue. And the ratings are the green dots. That's all, okay? We don't have any item attributes or any user model because in this context, very well, they don't make sense. They don't help us understand and, well, recommend something to the user. So inside TripAdvisor, there is a really, really big table in the database with all the hotels, restaurant, venues in general, all the users, and when the user rates a venue, we put this value here. If we want to compute the rating of a particular venue, well, it's just the average, okay? Of course, it's more complicated than that, but I think you get the idea, okay? It's just a simple computation, no personalized in any way. A bit different is a content-based recommendation. In this particular model, we just have, again, users which rate items, and then we build a model of user preferences, and we use this model to look for similar item, okay? So let's take the movie domain. The items are the movies. Item attributes or properties are actors, directors, and stuff like that. On the other side, we have user with some attributes, again, demographic, age, gender, location, stuff like that. And the rating, they could be stars, okay? In that particular example, I rated Rogue One 4 stars on 5. Okay, so in that particular case, we build a user model which could look like that. We have a list of different attributes like action, sci-fi, or the name of an actor. And for every one of those objects, we have a rating. We use this model to look for items inside our document base which match this particular model. I won't go in the detail of how to do that, but there are a couple of links you try to find, you try to follow and learn. from that, well, this kind of stuff actually could be implemented using a search engine. So if you use Solr or Elasticsearch, well, if you use Elasticsearch, you should know that there is a score function you can customize to your needs. So using that, you can just implement a content-based recommender system. But as I said before, I won't go into details of that. I want just to mention it for the sake of completeness. Which problems or limitations there are with this approach? Well, we need to know the content of the items, again, because we need to search instead of the content. There is a problem called user cold start, which means when a new user enters the system, it doesn't have a user model. So it's difficult to, well, recommend something meaningful to him. We need to, well, let some time pass, let the user use the platform, started doing some rating, and after that, we could start suggesting him something. Another problem, what if user interests change over time? Which, let's say I have Netflix in my home with my girlfriend, so we watch a lot of love movies. Then we broke, and then I start to watch action movies. So my interests are changed over time, okay? I don't want Netflix to recommend me love movies anymore, okay? And another problem is the lack of serendipity. Serendipity is finding accidentally something that you might like, okay? With this kind of approach, well, you cannot really doing that. The third approach to recommender systems are collaborative filtering algorithm. They try to overcome some content-based recommender system limitations, like you don't need to analyze the content. You can capture more subtle things, and they allow to serendipity, so finding stuff, well, you might like. There are two kinds. We're going to see two kinds of collaborative filtering approaches. The first one is user-user recommendation, which means I want to find user which share my tastes and use their opinion to have some sort of recommendation or suggestion. So the idea is I find a set of person which shares my tastes, I combine their opinion, and then I extract a recommendation for me. This is a typical scenario. Again, we have a really, really big matrix. On the rows, we have users. On the columns, we have movies. For that particular example, it could be, again, menus, hotel, restaurants, whatever. Here we have the ratings all the user gave to, well, the movies they have seen. In that particular example, which users have similar tastes? Okay, let's say Tom could share my taste because we rated some movies in the same way. So probably Tom is a good indicator for that particular movie. He gave a 2 to IT, so I probably I'm not going to like it. Okay, so the idea is pretty much this. Another different approach is item-item recommendation, where it works in a pretty similar way. In particular here, we are going to find items where I have expressed an opinion and see how other people felt about it. And in that case, we pre-compute similarity between items, and we use that to, well, again, extract some meaningful recommendation for us. So in user-user recommendation, we, well, basic reason with the rows. Here we are reasoning with the columns, okay? So in that particular example, let's say that the movie E.T. could be similar to this one. Make sense? Okay? More or less? Again, feel free to stop me if you have questions. Okay. What are problems or limitations of this particular approach? First one, sparsity, which means that when we recommend for a large item set, well, the user will have rated only some of the items. Think about Amazon, okay? How many of you bought books on Amazon? Okay, a few, yeah, a lot. And how many books have you rated on Amazon? A few, let's say 10, 20, okay? 100, let's exaggerate. Okay, well, on Amazon, they have thousands and thousands of books. So this big matrix is sparse, is really, really low populated. And this is a problem because it's difficult to find similar items. Again, user code start. When a new user enters in the system, we don't have enough information to make some meaningful recommendation for him. We need to wait a bit. Another problem is called item code start. It's the same but for items. When a new item enters the system, we don't have enough information to, find similar items to him. Okay. Another problem is scalability. When you have a lot of ratings, a lot of items, computation to find similar items, similar user, they become slow. For this reason, there is an approach, which again I just want to mention, which is called dimensionality reduction. The idea behind that is we are not going to use the whole big matrix. We try to extract some meaningful feature from the matrix, which is a small subset, and just use them for making comparison and, again, giving suggestion to our user. Okay, a quick example. Let's say we are in this particular domain. We have these items, 1, 2, 3, 4, 5, these users. And we want to, try to find how similar are Joe and Tom, and Joe and Bob, and stuff like that. And we want to recommend to find which is the rating Joe is going to assign to this item. Okay, so we need to find a way to compute similarity between users. Well, a naive way of doing that is just we consider only the items we both users have rated, and for each item we compute the difference in user ratings, and we take the average, which is, again, the simple way we could do that. So for these particular items, we want to find the rating for these items, and we start comparison Joe with Tom, Alice, and Bob. For instance, the similarity between Joe and Tom is 8 minus 2 plus 2 minus 7 plus 7 minus 5, which is 4.3. And we do the same for Alice, for Bob, and so forth, and so on. Please notice that the lower, the better. Okay, so in this particular case, Bob is more similar to our user, Joe. See? 8, 7, 1, 1, 2, 3, 7, 8. They are pretty near. Okay, after that, we normalize this data using this formula. Again, it's a really naive way of doing that. And so we get this measure of similarity. And we're doing so for all the users in the system. After that, we want to recommend what similar users have rated highly. So we have a rank of our users and how they are similar to me, or to Joe in that particular example. And we give the weight we calculated to the ratings the user gave to that particular item. So we are doing basically a weighted sum. So the rating of the item tree by Joe is going to be 1.57 multiplied by the rate that Bob gave to that particular item. and you do the same for all the users. In the end, we end up with a 4.3 predicted rating. Makes sense? More or less? Okay. Again, that's a pretty stupid way of doing that. Not stupid, but it's really simple. It's naive, okay? The real algorithms are more complex. But still, you can get the idea of how things work underneath. Okay, in order to recommend some items, you can use the entire matrix, but if you have a lot of users, that, well, probably is not doable. So you're going to use a nearest neighbor algorithm. So you try to find users which are historically the same taste of you, and you use just a subset of all the users to compute the recommendation. And in that example, well, we use a weighted sum to aggregate all the result, where the weight depends on the similarity, which is basically this computation. As I said before, in reality, algorithms are a bit more complicated. For instance, the similarity measure, it will be probably similar to cosine similarity or stuff like that. Again, I won't go too much into detail, but the idea is every document can be represented by, every item can be represented by a vector, in this case, a two-dimensional vector, and the cosine just give this angle, which means that when two documents have the same ratings, vectors are aligned, and the similarity is 0, which means they are the same. When this angle is not 0, it means the item differs. Again, it's just to give you an idea of how real calculations are performed. So let's get back a bit to our domain. As I said before, the domain is an online bookstore for both digital and paper books. And we wanted to recommend titles, both old and new. And because, well, some user just want to collect all the books, so it makes sense for this particular domain to just recommend also old books. And we want to, well, provide the user two kind of information. Who bought this also bought that list. So if you bought a book, you might be interested in booking also that one. And you might like list. Okay, so you have bought this book. Okay, you probably will like also these titles. Okay, so after a bit of study, well, it was time to choose the tool to doing that. And when we started the project, there were several, not so much alternatives, to be honest. And we tried some of them, and in the end, we chose Prediction.io, which is a project now under the Apache umbrella. It's based on solid open source technology, Java, Spark, and stuff like that. It has customizable templating engines and as an SDK for PHP, which means that as an XDK for every other language, because PHP comes always last in this kind of stuff. The architecture is not really complicated. We have two big entities involved. The first one is the event server. The event server is the one in charge of recording the user behavior. Okay? So let's say user action like the user viewed a particular page, the user bought a particular items, and stuff like that. The event server passes all this information to the engines. Engines are the part of the system that take the data, perform computation based on some algorithm, and then they create recommendation, suggestion for the user. The nice thing about prediction is that it provides a REST interface, so putting and getting data is pretty easy, simple. Okay, you can install it in different way. Probably the fastest way today, if you want to try it, is, well, Docker images, or there are AMI pre-baked images on AWS. Also, you can install it via source code, but if you want to just give it a try, it will probably not worth the effort of doing that. Okay, thank you. And, well, you can choose different kinds of storage. Elasticsearch is born to be distributed. So it's based on technology like Elasticsearch and HBase, which means that you can have multiple nodes. But if you have, let's say, a smaller problem, a smaller application, you can also try to run it on a single node. And for that particular case, you probably want to choose MySQL or Postgres as data stores. Okay, let's talk a bit about the event server. Well, as I said before, it's just the part of the system that collects all the information from the users in that particular pattern, user, action, item. So these are 3 examples of the events we collect. User 1 purchased product X. User 2 viewed product epsilon, and stuff like that. In order to create a new event store, you need to create an application inside Prediction.io, which will contain both event server and the engines. When doing that, you get an API key that you can use to issue REST request. And then, once you do that, you can start the server in this way. By default, it runs on port 7070, and you can curl it to see if it's alive. After that, the server is ready to collect information. Okay, as I said before, you need to pass the access key in order to be able to perform queries. Okay, which kind of event should we or can model in our system? Well, they depend on the algorithm we are going to use. Usually, it will be something like rate, like, by, view. Okay. Here's an example of how to save some event. In that particular case, we are saving an event called myEvent, which is performed by the user with this particular UID, and also we can specify different properties, custom properties for our domain. Another example, here we are saying that the event, myEvent, performed by the user with UID as an ID, is an action performed on the item with this particular ID. Okay, pretty straightforward. Okay, some examples of event. Here we are recording, for instance, a view event. So the user with the ID1 viewed the item with ID1. Here, the user with ID1 rated the item with ID1 with a rating of 4. So we started collecting this kind of stuff. Okay, there is, well, an idea of what the SDK allows you to do. Set user on set, delete, set item, record actions, which is what I showed you before. Engines. Engines are the part of prediction which performs, well, all the heavy work. You can choose between templates, which means that every template will be able to perform different recommendation algorithm, or in general, actually, machine learning algorithm. They're all based on this architecture, which is called D.A.S.E. Basically, every template is made up by 4 parts. The first one, data source and preparation, is the one that gets the data, the raw data, and pre-processing, and then passes it to the algorithm part, which performs some computation. while the survey part is the one that will answer where we ask prediction for recommendation and suggestion. The evaluation part is used to, well, understand the performance of the engine itself, if it's performing, if it's giving to the user good recommendation or not. Okay, here is how you can install a new template with PIO template get and the name of the template. Then you go inside, it will download the template and install it on your machine. Then you go inside the template directory, and you need to customize two different stuff, at least. The first one, the name of the application, which is the one you created before, and the events you want to track. So here we are saying, okay, this engine will track the buy and view events. And also you can assign different weight to the events. After that, you can build your engine, you can train that, and you can deploy it. After that, the engine will start run as a service on a given port, and then you can issue some queries to it via a REST interface. Get a recommendation, which is, well, all this stuff is about. Again, with the SDK is pretty simple. We connect to an engine. In that particular case, port 8000 on localhost. We send a query. Here we are saying, for the user with ID 1, give me 4 recommendation. Here is pretty much the same, but we are passing an item ID. So in that particular case, we are saying, OK, please give me 4 similar items to this one. So we have both stuff we need, similarity and recommendation. The output of the queries is something like that. So a list of item IDs with a score. And then we can use the item to, well, load our items from the database and, well, doing all the work. So how we implemented it in our particular case. Let's get back to love books. Two kinds of different suggestion. Who bought this also bought, recommendation. And you may like, similarities. We tracked these events, view. So when the user view a page, we recorded that. The same for like, which was recorded when a user added to basket or to wish list a particular item, and the conversion, so when the user bought a particular item. All these events were saved in a queue and then recorded in batch because we want to, well, delay the user interface too much. We created 4 engine because, well, at that time prediction was still pretty alpha, 2 for books and 2 for ebooks. Now it will not be needed. And we retrained every night the engines with the new data. So as long as the user continue using the system, we retrain all the engines in order to have fresh information and give them meaningful recommendation with the new data. Okay, this is a really small API we created. Doing that is pretty much all we needed. So record like, record conversion, record view, and create user. They are just theme wrapper around REST API calls. And those are the 2, again, SDK primitives to get recommendation and get similarities. Again, theme wrapper around the REST call I showed you before. Where we showed the recommendation, well, in a lot of pages, in particular, detail page for books and ebooks on the bottom, and in sidebars, in email campaigns, and stuff like that. When we haven't enough information for a particular user, well, we switch to non-personalized recommendation. So if a particular user is new and we don't have a recommendation for him, we just show to him like bestsellers or top-rated books and stuff like that in this way. Okay, that's pretty much the same. Before closing, I want to mention some alternative approach we found during when we're studying and learning this stuff. Again, for the sake of completeness. Here is a really, really good and maintained list of recommender system, both libraries, services, server, and if you want to, well, get into details or learning a bit more about all this stuff, this is a good starting point, in my opinion. Okay, an alternative approach is using recommendation as a service. Okay, for our particular clients, we weren't allowed to put data outside the platform, so we were forced to use an in-house server, but maybe for you it's enough to just use a recommendation as a service approach, which works in the same way prediction works. So you have a server, you send the event, you record on your platform, and then you ask for suggestion. Good, pretty simple. You can try to code it on your own. Well, if you want to learn how stuff works underneath, it could be a viable solution. I personally won't suggest that, but if you want to learn, this is a good starting point. GER stands for Good Enough Recommendation. It's a JavaScript project, really, really small and simple. All this logic is in 2 files, one for the event store and one for the algorithm. So it's really, really simple. And if you want to, well, again, understand how stuff works underneath, this is a good starting point. Graph databases, okay? How many of you know about graph databases? A few, okay. They can be used to do this kind of operation. Basically, you model your domain with different nodes, and every node has a different meaning. So here we have a node which represents user. Here we have nodes that represent restaurants. Every node is connected by an arc, which again has a particular meaning. Here we are saying that this user is friend of this one and this one. And here we are saying that this user likes this particular restaurant, and the same here. So by navigating this graph, you will be able to retrieve some suggestion for the user. Again, it's an alternative approach. I thought it was worth mention. Okay, so I finished. Thank you for listening. I am Michele Orselli. I'm CTO and partner in Ideato, which is a company based in Cesena, but actually we have distributed since we do remote work a lot. And we work with web technology, PHP, JavaScript, both front-end, back-end, and we like to build stuff and helping our clients doing so. Thank you for listening.